Hello everybody, is my voice audible? Yeah, so I think there are few members are about to join, so let's wait for 2 minutes before we start. Okay, everybody, so I think we are all good to start our day. So let me try to share my screen. So yesterday, if you remember, what we have developed was MongoDB related idea that is called replica set. And this replica set, what happened here? If you see in replica set, we have got this primary server. Okay, so we have got primary server and we have got two secondary servers. This is what primary server and this is what secondary server. Okay. So whenever we talk about a term name for primary server and secondary servers are this primary server, whichever we have created. Okay, so this primary server will get connected with what? This secondary, and there's a one with this. So whatever data you basically try to insert as a user, if you are a user, okay, if you try to perform any insert statement, it goes here. Okay, so this is an insert statement, and this data get copied where in both the files. Okay, so as I said, this data will get copied where in both the files, and this condition, whichever we're talking about, is known as called what? Is known as called replica set. Getting it? What is known as called? It's called replica set. what actually happens? This I want to tell you. Actually, what happened in primary server, there's one file name called oplog.rs file. Which file? Oplog.rs file. This oplog.rs file is available under where? Under the primary server. And this oplog.rs file will get copied, okay, to all the secondary servers automatically. Because this oplog.rs file contains the data which needs to be get copied where? To all the child servers. That is the oplog.rs file. This oplog.rs file which is available. Okay, I tell you about something about this oplog.rs file. This area of the oplog.rs file, whichever I'm trying to give it to you. Okay, it is the one which will be holding all your necessary files which you will be able to see into your code. Remember one thing, the default size, sorry, default size of oplog is 5% of disk space or 5% of disk space. It cannot be less than 900 MB and cannot be more than 50 GB. Remember this. What I said, this oplog.rs file by default it takes 5% of your entire disk space. So it cannot be less than 900 MB. The minimum size will be 900 MB and the maximum size could be what? 50 GB. That I'm telling you about a default. Are we clear? These conditions can be increased or decreased based on the requirement, but this is how it is available. Are you clear, everyone? Guys, are you clear? Okay. So if you want to check about this oplog.rs file, so please connect with your primary server first and all your secondary servers and type done in the chat window. Please connect with your primary servers and secondary servers. If they are connected properly, type done in the chat window. And let me know by typing done in the chat. Friends, please update if you are able to connect with your servers. Okay. Kaushal, so if you're done, can you please help me to share your screen? Okay, so you're in primary. So in primary, just say, yeah, so you're in primary. So you just say show DBS. So we have one database name called local. Just say use local. Yeah. Now it says show collections. Okay, now can you see some option which is available here called oplog.rs file? Yeah, so open this oplog.rs file. Okay. Now here you see there's an option available called db.oplog.rs.find. Yeah. Okay, so you got this details with you. Okay, so the details are available here. Call whatever the details of the oplog.rs file. Okay, so this oplog.rs file will be able to add it into your local environment. Okay, now once it is done, you can just type one command called db.oplog.rs.stat. No, stats, not stacks, stats. These are the statistics which are available here, which you can see about your oplog.rs file. Okay, so capping they have given true. That means it is responsible for having the limitation, and you can see the other options which are available in your applications. Okay, so it's done. So it is almost ready for my development. So yeah, this is it. So do one thing, just try to add one more server, create one more server for DB4. DB4 is already there, DB5. Same way the way you added it earlier, those number of lines. Just wait, don't say rs.add. Okay, in fact, you have to add another type of servers here. Okay, so you have to make it as a what type? Arbiter server. Just say rs dot. Yeah, so what I'm trying to say, you have to add as a what is our arbiter server. So the logic will be a little different here. Okay, so just type one command called rs dot add arb, a capital arb. No, not dot. Rs dot add arb, a capital arb. That's called arbiter. Now start the round brackets and give the way you are giving for. You can see this is the arbiter server now. Okay, now you can call this function, guys, everybody, it is for everyone. Just type this command here, the one which you would like to launch. No, not this one. The command called rs.status and rs.conf. Start a round bracket, set enter. You can see it is an arbiter node. Now you might be thinking, what do you mean by arbiter node? Arbiter nodes are those nodes which never store any data. Again, I'm repeating. Arbiters nodes are those nodes which never stores any data. Rather, they will be playing a role of what? Of just like in, you can say, a kind of a voter. They can vote in case if you have less number of nodes, but they will never be participating in storing the data. Unlike other nodes which stores the data, they will never be storing the data, but rather they will be responsible for voters. Okay, they will vote for the next primary, but they never be a kind of primary node. So guys, check and let me know if it is working fine. It is telling you it is an arbitrary node only. Hope you guys are clear. Please everybody check the same and let me know if it is working fine. I'm waiting fine for all of you. Please update me. Everybody update me if you all are ready till here. Okay, so one more important thing I would like to say that is called delay. So sometimes it happens when you would like to delay the server to respond the data, that also you can delay that. What you can do is just same thing what you did it last time. Just say cfg equal to rs.conf. In a primary type cfg equal to rs.conf. cfg equal to rs.conf. cfg equal to rs.conf, start the round bracket. No, not here. There inside your main server, primary. Yeah, enter. Suppose you want to delay the specific member. Okay, which one is your primary, may I know? One, two, or three? Which one is primary? Which server is primary?
20, 20, 20. We created forcefully 20 as a primary.
No, that is no. Which server? 2310123. Which one is primary?
4, 4, 4.
Fourth one is primary. But fourth one is
Yes.
arbitrary.
No, third one, this one.
Yeah. So you make second as a what? As a delay. So just say cfg.members cfg.members. But did you say rs.conf? cfg equal to rs.conf, did you say? Yeah, type cfg equal to rs.conf again. cfg equal to, yeah, enter. And now you type cfg dot members, start the square bracket, put 1, close that, dot secondary delay, secondary type, secondary delay, D capital, SECS, SECS, S capital, S capital, SECS seconds. Now you have to provide how many seconds? Now you say equal to 20. That means this member will be expecting the data after 20 seconds. Okay, hit enter. And now you say rs.reconfig, rs.reconfig and pass cfg as in parameter. Enter. What it is saying? What it is giving this name? Operation time. Yeah, that is correct. cfg dot, what you have written? cfg dot members. Okay, can you do one thing here? Just press the up arrow key where you've written this. Here, rather than saying secondary delay seconds, rather you type slave delay. Type slave delay. Slave delay D capital. Enter. And now you say rs.reconfig and pass cfg as in parameter. Yeah. Can you call this CFG again? Same message about to say rs dot no, not this. No, above. Yeah. Now you pass the value members. Hmm. Now it's rs dot reconfig. Okay. Do one thing. Priority must be 0. Okay, got it. So do one thing. In that case, press the up arrow key again. Up arrow key again. Yeah. Here before you just press enter, and again you say cfg dot members 0. Sorry, members 1. Members 1. Put 1 dot priority equal to 0. Equal to what? 0. Yeah. Enter. And now you say rs dot reconfig cfg. Yeah. Yeah, now it is working fine. Now it is saying okay. Okay, one means it is working fine. Now what would happen? Now what would happen here? This time, if you try to send any record from, suppose if you insert a new record where inside your primary, so secondary will receive the new record after 20 seconds. If you want, you can try this out. Guys, please make sure that is also working for you. So are you understood? Kaushal, what I said?
Yes, it is received after 20 seconds. If we are inserting into the primary, so
Yeah,
there is a 20-second delay.
delay. But all the others will receive the data on time. But this will be receiving after 20 seconds. Okay.
Yes, yes,
Okay, so you can try and let me know.
yes.
Try to add a record from the primary, Kaushal, and check if it is added into your secondaries or not after 20 seconds.
Yes, I'm checking into secondary, getting this error.
Who is getting error?
Something error. If I'm trying to find, so it is giving error operation. Something not master or slave. Okay, equal to false.
You have to say slave equal to true, no? rs dot slave, okay, true.
Not to into each time we have to execute that.
Yeah, just try. Slave, okay, slave, okay, slave, okay. And start a round brackets and say true. Enter. Yeah, now you type the same command, the one which you were asking for. Show dbs.
Okay, now into each time we have to execute that.
I think by default it is always false, right? Slave okay.
Yeah,
So we have to do that for all the secondary servers, right? So the secondary
yeah,
node.
absolutely.
It is a 1.9 and it is a I want 1.8. Yes. I am not able to see whichever collection is created into primary, not present into the secondary.
No, don't go to the local. Just come out from the local.
Okay.
Create a new database Are we clear? You come out from the local, say use new DB or something like that, and
Okay,
then you
okay.
should move.
Yes, got it. Now it's a 20-second delay.
But others are able to receive on time. Just that's it. That you also check.
Here I'm received it on the same time, and but here I'm waiting for the check that also.
Cool.
कौशल कमांड ये करेगा क्या, शेयर करेगा क्या?
हाँ, शेयर करता हूँ.
Just wait for the others to finish, okay? Guys, please quickly finish and let me know if it is working fine so that we can go ahead. Okay, so everybody, time is up. I'm sure like you all are clear about how this replica sets and everything works. Okay, so everybody, so before we proceed ahead, can we go back and take a break now? Yes, everybody. Before we proceed ahead, can we go back and take a break now? Okay, so let's take a break now. We'll be seeing you back in another 10 minutes to resume our session. Okay, thank you. Hello everybody, so are we all back from the break? Hello everyone, please confirm if you all are back from the break. Everyone, so let me share my screen now. Okay, so everybody, we have seen already a lot about one concept like in what a replica set. Now we're going to talk about something very interesting topic here that is also called sharding. What are you talking about, everybody? Sharding. Now, what exactly the sharding is and how it is different from the replica set, that is how I'm going to tell you now in my application. See guys, when we talk about called sharding, sharding is taking a complete replica set to the next level. And here in our sharding, we basically try to configure our application even for the most highest availability. Okay. Now, if I just show you about one very simple option of starting in MongoDB, if I show you about the images, you will get to know about the exact MongoDB architecture, the one which you are actually looking forward for. See what is happening in your system. Say this example here. This is your sharded behavior, like how you're gonna be talking about horizontal scalability. Okay, so this now here, MongoDB sharding. So you see like the first option what we are having it now, we have a called application. Everybody here we have a call application, we have a call driver, we have a call routers which are available, and here the routers are basically trying to send the data where to the multiple shards, and every shard will be having what primary and secondary nodes. Every shard will be having what primary and secondary nodes. So what exactly the sharding really does? See, in sharding, what actually happens in sharding now is you have a got application which is your front end application. These are basically the routing servers which are available. These are a config server which knows it very well where your data will get stored here. Okay, so from there you will be able to send this data to where, to your multiple URLs wherever the options are available to us. Okay, so this is known as called what MongoDB sharding architecture. See, normally what happens whenever you are connecting with this kind of application, so client when they will be retrieving the data, whenever they'll be retrieving the data, they'll be retrieving the data from where, only from the S1 and S2. Clear? And they might retrieve the data from the primary node. So while sending the request to your MongoDB, they have to pass the IP addresses of all three machines. Then only they'll be able to retrieve the record. So tomorrow, if any of the server is goes down, you won't be able to understand from where to query. So you have to go back and change the client also. Clear? In MongoDB, when we talk about called what? Sharding. Everybody, what we're talking about? Sharding. This concept goes in a complete different direction. Because when we talk about a term name called what? Everybody, sharding, we always talk about a concept from where you will be communicating with your client, and from there the rest of the requirements will take place. Okay, now you can see we have a called primary node and secondary nodes which are available. So for time being, I'm removing it all. So this is your primary node and secondary nodes. Okay, likewise, with another. Are we clear? Likewise, this will be the another. So if you see here, total we have got how many? Everybody, total we have got how many? Total 3 are available. Okay, total 3 are available, primary and secondary nodes. And remember one thing, they will be the part of what? Sharded cluster. They'll be a part of what? Sharded cluster. So under the cluster, we'll be having the options like this. Okay, so here we'll be having the option like in what? Config server. What I'll be having it? Config server. And if I just take this, okay, so I just remove this. Yeah, so I'm talking about they are called what? Sharded cluster. Here, if I just increase the size, yeah. So here in your application, you will be having this option like in C1, C2, and C3. Let me put it here. Okay. What they are? They're basically called config replicas. This is called config server. These config server knows it very well where your data is stored whenever you are trying to insert the record. So these config server knows it very well where the data is getting stored, and they will be communicating through what? Everybody, they'll be communicating to what? To their respective nodes. Are you clear, everybody? Because they know it very well how to communicate, and this is known as called what? Everybody, config server. Okay, and this is the config server like in what we have called. It will be like in same. It will be like in same. This is called what? Come on. Primary. This is called what? Secondary. This is called config server. They know it very well how to communicate with what? Everybody. How to communicate with what? To the other servers, because they know it very well, like where the data is actually stored. Because whenever you try to insert a record, suppose if I'm adding 10 records, or suppose 9 records. So typically what happens, the record in typical replica set get copied equally across S1 and S2. But in sharded, what happens, whenever we are adding 9 records, so data get equally distributed across multiple what? Replica sets. So 3 records will go here, 3 records will go here, and 3 records will go here. And these 3 records will get copied equally under S1 and S2, S1 and S2, and S1 and S2. So you can understand earlier the 9 records get copied equally under S1 and S2 under one particular replica set. Here, when you insert the 9 record, 3 records will go here in first replica set, second will go here, and third will go here. Are you clear, everybody? Everyone, please confirm. Are you all clear?
Yeah, so there might be possible, right, that multiple config servers will be available for that.
Yeah, because config servers, there are multiple config servers are available. See, this is a one config server, there's another config server, there's another config server. But they're once again used as in what, as a primary and secondary, just like them.
Okay.
Okay. And in front, you'll be having what? This. Okay. And this is known as what? See, these are basically working as a load balancer for you. They are load balancer. Config server is a load balancer for me, and this is called what? MongoDB. If you see the architecture here, we have a call what? Router. Okay, so here we talk about what MongoDB, and this is what the front end of your application. Are we clear? So your client will communicate to whom? Raji, your client will communicate to whom? Come on.
MongoDB.
MongoDB for any insertion, updation, and deletion and retrieval. So this is what the architecture of what of your sharding.
Okay.
And I want this to be very much clear to everybody's mind. This MongoDB, whatever we're talking about, is the front end to communicate with what? With your all backends whichever are available.
So like the data distribution that happens, it happens equally, right?
Yes, data distribution happens equally.
So there will be always like whenever we send the data, it will be divided in uh, three equal parts
Yes.
because we have three primary and secondary configurations.
Yes, very much. So this is how exactly the shards work.
If we are inserting 10 records, means the first primary will get 4 records like that.
Sorry, once again.
If we are inserting 10 records,
They'll get equally distributed 3, 3, and 4, or whatever it is, like that.
Okay, so it is not our headache. It is config server's headache that while
Yeah.
fetching that data, it will fetch it from the these primary secondary servers
Yes,
automatically.
very much, very much. And remember one thing in this, there's no arbiter is allowed. There's no arbiter is allowed here.
Arbitrary error, yes.
Okay, in our previous example, we have kept an arbiter. Here, there'll be no arbiter is allowed.
Mhm. So that means in this sharding structure, there won't be any arbitrary available, right?
No, there'll be no arbiter node.
Okay. So now we have created the primary and secondary servers. So these config servers also we need to create it, or it will be automatically created by MongoDB.
Which one?
Load balancer.
Load balancer, we only have to create. See, the whole structure, we only have to create it. It's
Okay.
nothing would be available free of cost. The whole thing has to be taken care by us only. But you can understand how many servers we needed. 1, 2, 3, total 9, 10, 11, 12. And how many? 13. So 13 servers you needed minimum in your local machine. Does your machine have a capacity to hold all? Come on, everybody, I'm asking. Does your machine have a capability to hold all those?
No.
Because your machines may not be capable enough to handling 13 servers back to back.
Yeah, that's why
Because,
we use cloud architecture.
yeah, that is why we may need a cloud architecture to support all those. Because see, ultimately what would happen in AWS tomorrow, you may be having what? Multiple clusters. See, cluster does not mean that all servers will be running under the same machine. You're getting it?
Yes.
Cluster means what?
The servers are interconnected, but will be available on different machines.
Yes, different nodes, I can say.
Yeah, nodes.
In local IP addresses, we can also run it, but there'll be no use. But for you, it is essential to understand what this sharding architecture is, because this is something which you people will be using it a lot in your future in case if you need it.
Yes.
Any questions from anyone?
No, I'm good.
Okay. From anyone else? Okay. So if it is ready, then we would like to talk about our final topic of our MongoDB. And remember one thing, Monday will be developing our mini application. What is it? Monday will be developing what? Come on. A
Mini
mini app
application.
where you will be, whatever you have learned so far, React, Node, and MongoDB, will be developing a mini application to connect all three things together. Is it as exciting? Come on, everybody. Sounds exciting? Because we have learned MongoDB, we have learned Node.js, we have learned what? ReactJS. It's time for us to basically collaborate all three things together. Okay? And connect all three so that when you shoot any records from ReactJS as in front end, it'll go to where? Node.js. Node.js will process it and send it data to where? To the MongoDB. And MongoDB will be connecting it to where? To our replica set. So do not destroy this replica set. Kaushal, are you able to understand? Kaushal, are you able to understand? So don't delete your cluster, because same cluster will be connecting it to communicate. But I want to take a snapshot of this sharding so that it will be easy for you to all make it possible. Okay. What do you want me to share in a chat, Ranjit? This is not possible, Ranjit, because this diagram is there under the this predefined URL, so it won't be available. So you can take a picture from your mobile, so just you can keep it available. Okay. So we're going to talk about our next concept here, that is known called transaction. And I'm sure like everybody is eagerly waiting, like in case in MongoDB, if I have any kind of option like in transaction, how to do that, isn't it, everybody? Okay. So Kaushal, can you please help me to share your screen again?
Yes, shared.
Okay, so do one thing, create a new database inside your MongoDB, give the name called transaction DB.
Amarjit, I have one question. Just going ahead before that. What is the difference in both of that, like sharding and partitioning?
See, sharding is nothing but a logic of partitioning, because sharding does the partitioning of your data, no?
Yeah, so it's same, right? Vertical scaling and horizontal scaling both.
Basically, it is a horizontal scaling. When you talk about sharding, it is a horizontal scaling only.
Okay.
What to give the database name?
Transaction DB. So in this transaction DB, create a new collection name called people. Okay, so db.create collection people. Okay. Now I want you to add minimum three what to say records inside this. How many? Three records I want to add it with using ID and name. Only these two properties, ID and name, and add the ID custom. Okay, only add ID and name and add three records inside this new record. Okay, so 3 records are added. Now what you can do, you can start the new logic now. Just say session equal to db.getMongo, db.getMongo, and capital. Start the round brackets, dot start session. After the round brackets, dot start session as capital, session as capital, start session. Yeah, hit enter. You can see your session has been started and session ID has been given. Okay, now I want to write the new logic here. Just a session.start transaction, session.start transaction, session.start transaction. It's a round bracket, enter. Okay, your transaction will begin. Now I wanted to add 3 more records with different values.
So here also 3 record to be added again.
Yeah, with the new values.
Okay.
Added the 3 records. So total, how many records you are able to see? All 5 records or all 6 records, whichever you are having it.
Yes, yes.
Okay. Now type one command. First of all, you type db.getDatabase, db.getDatabase. Start the database name with the round brackets. The database name in double quotes within round brackets. What's the database name? Transaction DB or what? transaction DB, come out. And now you say dot collection name is what? People dot find. Put the round bracket, enter. Session.get database, not db.get database, session.get database. Enter. So what you did? So you tell me one thing total, how many records you've added?
6 records.
You've got total
6.
Okay. Now do one thing. Just type one command call. Just type one command name call session.commit transaction. Session.commit transaction. Start the round brackets. Enter. Got it?
Yes.
So this is how you're basically committing it, and call the find function again. And call the normal find. Yeah. You are able to receive the record, the one which we are doing it now. So what I need to do now, I would like to start the another transaction. So what I'm doing it now, I'm sharing with you one document. You follow the documents and perform all the operations one by one. Is it okay? Come on.
Yes.
Okay.
Yes.
Prakash, Gaurav, Avinash, please confirm. Are you all clear? Okay. So now do one thing. Go back to the code share. Do you guys have a code share link with you? Everybody, do you guys have a code share link with you? Okay. But remember one thing, do not copy and paste these things one by one. Copy and paste this into your local notepad and post that, type those things manually and check whether the records are being used, followed as per the same used or not. Okay, so please continue and let me know. Prakash, Avinash, Kaushal, have you received this data? Kaushal and everybody, I'm sure like you people have started. Kaushal, Prakash, Gaurav, Ranjit, I'm sure like everybody have started. Okay. Kaushal, Prakash, Gaurav, Avinash, Ranjit, any update about the transaction related part? Please update me the status. Kaushal, any update? Okay, no problem. Take your time. Good job, Ranjit. Ranjit, may I know like what exactly finally you understood with this entire logic? Could you please help me to explain?
Yes, actually we are creating sessions and after committing that only reflect. Otherwise those transactions or modifications will not reflect in the database. Hello.
You tell me, Ranjit, what you're saying?
Yeah, we are creating the sessions for safety purpose like that. Because in sessions we are doing the transactions like modification or inserting. Those
Okay.
will not reflect in the database. After committing, it will reflect.
Okay, cool. Are you able to understand in real time how the transactions are more useful here, especially for the MongoDB front?
No, I'm not sure.
No, I mean to say, are you clear about how the transaction works here? Because without commit, nothing happens. Agree?
Yes, correct.
So only when you're able to commit, you'll be able to see the records out. Yeah?
Yes.
Okay. Avinash, you have a same perception about this? Kaushal? Gaurav?
Yes, there is a one more thing. If two transactions are working on the same, so we can, if you are trying to commit, so it will throw the error.
Yeah. What error? Concurrent modification error.
Yes, so on the same database, we cannot create two sessions and trying to commit that.
And one more important thing is Kaushal, which is very, very essential. Your transaction can be working only on your cluster. Without cluster, your transaction can't work. You got it, Kaushal? If you work without cluster, like when you talk about single node, it can't work your transactions because transaction needs what?
Okay.
Your transaction needs what? Cluster, so-called replica set. Are you clear?
Yes, yes.
That is why the transaction topic I took only at the last, because unless you are clear about the cluster, you can't do the transactions. Are you clear, Kaushal?
Yes.
So these are the primary things which we need to understand whenever we attempt for any kind of new transactions. Do you have any question? Yeah, do you have any
I
question?
have one.
Yeah,
We
Ranjit.
are creating the sessions. So what is the
Yeah.
lifetime of that session?
So the
Lifetime.
session lifetime in the sense the session lifetime is for few minutes. Only for 8 minutes the session is active. If within 8 minutes you could not work, the session is automatically closed.
Okay.
Okay. And version to version, the timeout time is totally depend, but average is 8 minutes.
Okay, fine. We have committed one change, one transaction. We can undo that.
No, we can't. Once it is committed as per the rule, it cannot undo that.
Okay.
Because that is the rule of the, have you heard about solid approach, SOLID, solid?
No.
No, solid. If you type solid approach in transaction, there's a one last word called durability. SOLID, solid. There's a D stand for durability that says if the transactions are committed, it cannot be rolled back.
Okay, thank you.
Got it?
Yes, Amar.
Okay. So I'm sure everybody, whatever has been covered today, you all are clear. Okay, about MongoDB as well as administration's part. MongoDB is over now today. Monday will be having a mini project started. Monday will be focused purely onto the project, and Tuesday onwards we'll start working on ELK stack. Are you clear, everybody? Guys, Tuesday onwards we'll start working on where? On a ELK stack. Clear, everyone? Okay. So well guys, so that's it what we're keeping it for today. So hope you've enjoyed the session. Many things we have seen today in MongoDB administrations as well as its transactions. So I'm sure this has given you the solid understanding of what MongoDB is all about. Monday we'll be having a mini project, and Tuesday onwards we'll start working on ELK stack. Okay. So guys, that's it. We have it for today. So enjoy your day. Have a great weekend to all of you. We'll be seeing you back again on Monday to take this journey ahead. Okay. Till then, have a great evening to all of you. Have a great day and have a great weekend. Okay. Thank you and
Thank
see you
you.
back on Monday.